Hey, Algebra 2, I just wanted to send you a quick word of encouragement that even in my absence, I still want you to make today a great day of learning. The plan today is to let you work through this application assignment. There's 5 problems on here to try to get figured out. If you keep playing the video, you'll see that there's some hints and help. So it's appropriate to have your iPad out, to be pausing the video. Plus, you're going to get to use Desmos to solve all but one of these problems. I believe one of them you have to solve with substitution or elimination. So listen, you got this. You guys can solve these. Make it a great day. Let's go. All right, so just as a reminder, make sure you do follow the directions. Yes, you're allowed to use Desmos. You're allowed to use that Desmos method on your computer or your iPad to be able to solve the systems with matrices, but I still want you to solve one of the problems. The old-fashioned way. So you have to show the substitution or the elimination method. But you got this. You can just pick an easier problem and go ahead and kind of review using substitution or elimination. All right, I promised that I would give you some hints and help on each one of these. So let's take a look at the first one. Looks kind of like the first example that we did in class. So yeah, we've got the boat, we've got the stream. Remember that the B, it does represent the boat speed, but that's kind of just the boat by itself. And C does represent the current speed, but again, that's the current by itself. So you have to keep in mind that the boat is going downstream. The current is pushing the boat. So we're going to have to add B plus C. That's kind of like your overall speed downstream, but what about our speed upstream? What about when you're going like against the current? Okay, well, I'm going to let you fill in the rest of that. Okay, there's something that you're going to be filling in beside the letter B. Now, both of these we need 2 equations, and both these equations are going to come from distance equaling rate times time. Don't forget that that the distance is the same for both of these. So 100%, we've gone 336 miles. That's a long trip. But what was our rate? What was our rate going downstream? Well, that's the B plus C. I'm going to let you figure out how much time that took. The other equation has the same distance, okay? But now we have a different speed. It's the upstream speed. I'm going to let you figure out what goes in there and how much time. Okay, both of these need to be simplified. Both equations, you're going to need to distribute whatever number you end up putting there for time. And once you distribute, then you probably can turn this into a matrix A and a matrix B. Okay, don't forget that it's A inverse times B in order to actually solve that on Desmos. How about this theater problem? We got $6 tickets, $3.50 tickets, $2.50 tickets. A total of 278 tickets. Assuming that you guys are going to let X be the adults and that you're going to let Y be the students and Z be the children, but we do need to kind of make that clear. Then when you do your total equation, remember a total of 278 tickets, when you do that equation, keep it simple. Remember that that's just going to be adding your X plus Y plus Z. And I'll let you figure out, let me keep the colors consistent here. So you're just going to be adding X plus Y plus Z, but I'm going to let you figure out what that would equal. That's your total equation. You're definitely going to have another equation for the money. Okay, I'll let you think about how to write that money equation. Let's help each other with the third equation. The third equation. It says the number of tickets sold, or that is the number of adult tickets sold, was 10 less than twice the number of student tickets. That's kind of a mouthful, but it does say number of adult tickets was. So number of adult tickets was means that we need to be thinking about X equaling. you can basically say x equals, and now we can get to the business of thinking about 10 less than twice the students. Now, twice the students would be like some type of 2x. All I have to do is figure out how to write 10 less than that. Well, kids, that's going to be a subtraction problem. So I can subtract 10. I guess I just told you, so we'll put it in there in red. You can subtract 10. And, oops, I have a little mistake. Sorry about that. It was twice the student tickets. So it's going to be twice, that is 2y minus 10. Okay. Hey, you could solve that problem with matrices, but you're going to have to reorganize the third equation. You could also use the substitution method. Since you already know what x equals, you could substitute that in for x. And of course, you could substitute that into both equations. Number 3. This one's a little tricky. It's kind of what we would call like a mixture problem. What do we mean a mixture problem? Well, it's kind of like letter B from the examples, okay? But instead of us mixing chemicals together, we're actually mixing money. We're mixing money and putting them in different investments. Let me help you a little bit to get this situated, okay? First off, we have 3 different types of investments. One of them is like a savings account. So that'd be like kind of like something that is getting you a little bit of money in gain, but not too much. It's kind of conservative. It's a savings account. Then you have a money market. The money market gets you like 7%, so that's a little bit better. And then the last one is more of like a bond. So basically, there's 3 places that you can put your money: into a savings account, a money market, or a bond fund. Now, if there's 3 variables, x, y, z, then there's going to be 3 equations. And like many of these systems, one of your equations is the total equation. You want to think about how you can do a really simple total. And again, keep it simple, because when you total stuff, you just add it together. And it's going to equal the total amount of money that you have. You have $42,000. Okay, but you have to write something that's going to add together to be 42,000. Now, most students understand that the percentages are going to match with each fund. So yeah, 5% times x, or 0.05, 7% times y, which is 0.07y, and then 9% of z, 0.09z. So I'm multiplying the percentages times the actual amounts. But what you have to keep in mind here is that this is only the amount that you're making. This is like the amount that you made on the investment. Okay, here we have, it says that I made, or the total interest was $2,600. So you figure out, well, I just told you, but you're going to put $2,600 in that spot. That's the amount of money that you made. All right, well, we got one more equation to do. Okay, I'll keep helping you here. Okay, because here we go. It talks about the savings account was. Well, when it says the savings account was, that means that we can talk about something with X. But what you have to realize is that when we talk about the savings account, it's the interest from the savings account. Now, the interest from the savings account isn't just X, but it's 0.5X. Okay, but it was, so it's equal. It says the total from the 2 other investments. Now, students, the total from the 2 other investments is going to be the total shown right here is 0.7y and 0.9z. So you can fill those in. You can fill those in, and then less $200. It was basically $200 less than that. I got to subtract that. Okay, so do you know what you're going to be putting in this parenthesis here? You're going to be filling in this. Now remember, when you solve this system, if you decide to do a matrix method, you're going to have to reorder the equations, because I can't just turn this into a matrix until all the x, y's, and z's are on the same side. And then when my numbers end up on the other side, I can make that be my other matrix B. So you got to reorganize this third equation. You have to kind of move some numbers around. You got it. You can turn that into matrix A and matrix B. Problem 4. Problem 4. I'm going to let you guys do this one. You got it. You can just solve problem 4. It's really a simpler problem. It's just got x and y, and this might be one that you choose to use the substitution method or the elimination method. Okay, you can still do it with a matrix if you want, but make sure you choose one problem to use substitution or elimination. How about number 5? Okay, we're making boats. We're making 1-person, 2-person, 4-person boats. And then we've got different departments that kind of put it all together. Kind of sounds like one of those linear programming problems, but actually we can just set this up as a regular 3-variable system. I want to make sure you understand that X would be like the 1-person boat. In other words, how many 1-person boats? Y is your 2-person boats, and Z is your 4-person boats. Okay, so you got to kind of make the connection here that it's a half an hour for cutting. It's an hour for cutting. It's 1.5 hours for cutting. That's for each one of these. Okay, so half hour for every X, 1 hour for every Y, 1.5 hours for every Z, and that's just going to equal the total amount of cutting hours. Do we see that number up here? Okay, it's our first one. It says respectively, so cutting goes with 380. You're just going to continue building 2 other equations using this same sort of style. Okay, you're going to make 2 other equations, and then once you make them, I would definitely solve this using that matrix method. Remember now, you got to have a matrix A and a matrix B, and you want to use A inverse times B. The bonus problem. Well, it wouldn't be bonus if I showed you how to do it, okay, but it's kind of a neat problem. You've got 3 digits. Let your 3 digits be X, Y, and Z, and you can try to create 3 equations for each of those, create 3 equations that use those variables. See if your answer makes sense. All right? Feel free to go back and forth, come back to any problems. Do a great job with your assignment. You got this. Let's go.